Rami.
We are students from our STEM school, Egypt.
In this activity, we want to calculate the applied force that moves this block and lifts this loop. Before we start, you must follow safety rules to avoid injuries and errors. The equipments of our apparatus are force sensor, wooden block, 3 pulleys, 2 of them are fixed and the third is movable, a motion track, light string, hanger, mass is equal 300 grams, and ring stand. Don't forget, you have universal interface and Basco Stone application in our laptop. First step, we need to calculate the friction force between the plane and the wooden block. The coefficient of wooden block equal 0.23 and the mass of it equal 129 grams. Then the friction force equal 0.23 times 9.8 times 129 over 1000 equal 0.29 Newton. Now, in this direction, we have two forces, tension force and kinetic friction force. And in this direction, the applied force. To find tension force, we subtract friction force from the applied force. Now, we reset the force sensor by click on the 0 button. To do the experiment, we press record and pull force sensor, but take care, don't touch the light string. Now, we press the 0 button to reset our force sensor.
Record.
Now we pull our force sensor. This is our first trial and we will do it again 5 times. Now my teammate Khaled will explain the theoretical analysis for this experiment.
We will start our theoretical analysis for our experiment. To start with, we will show you one of our trials. The average forces of our experiment here was 2.1 Newton. We can show you another one. Here, we have an average of 1.9 Newton. Here, 2.0 Newton. In this diagram, this is the stand, the movable pulley, the fixed pulley, a fixed pulley, and a mass of 129 grams translated to 1.3 Newton, the force sensor, and the total mass of the pulley, hanger, and the masses, which is 331 grams translated to 3.2 newtons. Here we pull the force sensor in order to let this body move, knowing that the mu s we after calculated, which is equal 0.23. According to the equation of equilibrium, we have here the F applied should be equal to the friction plus tension, as we have here in this equation. The force applied we have calculated using the force sensor, which is equal from the summation of it, 2.1 plus 2 plus 1.9 plus 2 plus 1.9 plus 1.9 divided 6 equal 1.96 Newton. By substituting in this equation, we have here the force applied equal 1.96 equal the friction force, which is equal 0.23 times 1.3 plus the tension force. From this equation, the tension force equal 1.66 Newton. After getting the tension, which is equal 1.66 Newton, we here have mass of 3.2 Newton, as you remember, which is distributed into the string into two tension. Two tension equal 3.2, tension equal 3.2 divided 2 equal 1.6 Newton, as we have result. Difference here is equal 1.66 minus 1.6, which is resulted in an error of 0.06 Newton. The error percent here is 0.06 divided 1.6 times 100 equals 3.8% error.
By the end of this video, we wish you have enjoyed this activity.
Our greetings from Khaled and
Marawan and Khaled.